Okay, so looking at video lesson 5.8, half angle properties. Now, if you really understood double angle properties, half angle properties are going to be really easy to understand, very similar. Obviously, it's half instead of double. So if you look at the properties here, they actually kind of look somewhat similar, but there's some similarities here. With sine half x, we've got a plus minus square root of 1/2, 1 minus cosine x. And cosine 1/2 x is very similar, except we have the conjugate here. And then, as suspected, tangent of 1/2 x is basically the division of sine and cosine. And then there's actually a simplified version here and here, and it has to do with if we were to have multiplied the top and the bottom by square root of 1 minus cosine x, you could simplify it down. And so we have three properties. And again, to figure out which property to use, well, that just depends on what type of problem you have. One thing to clear up, though, at the very beginning is this plus minus. It's not that we have two answers, one's positive and one's negative. It's just that we don't know until we actually look at where 1/2 is. So it says the plus or minus is determined by the quadrant of 1/2 x, not plain x. So let's practice what this really means. So if I tell you that x is 100 degrees, or sorry, x is 200 degrees, then I want to find the sine of 1/2, cosine of 1/2, and tangent of 1/2. Well, what we need to do here, pretty simple. We just need to find, well, what is 1/2 of x? Well, that would be 100 degrees. Okay, so sine of 100 degrees. I don't know what this is, but I'm not asking for that. All I want to know is sine of 100 positive or negative? Well, what quadrant is it in? All right, 100's in the second quadrant. All students take calculus. Well, sine of 100 is going to be positive. What about cosine of 100? Okay, that's going to be negative. And then tangent of 100, that's also going to be negative. And so we're going to use this to figure out what the sine should be. Okay? All right, let's practice this with one more. So this says if x is 480 degrees, find the sine. All right, well, what is 1/2 x? Just take 1/2 of 480. Okay, that's 240. And if we draw 240, it's in the third quadrant. All students take calculus. So tangent's positive in this quadrant, but sine and cosine are negative. Okay, so it's that simple. Now let's actually use a problem. Now, normally when we get to problems like this, we would be drawing a triangle. We actually don't have to do that on this problem, and I'll kind of explain it why as we go along. If you were to draw the triangle, though, it would definitely not hurt you. But something you must do is figure out what this is telling us I'm in the third quadrant for theta, but I need to figure out what quadrant is 1/2 theta in. So if I take half of 270, that's going to be 135. And if I take half of 360, that is 180. So what quadrant is 1/2 theta in? Okay, it's in the second quadrant. Okay, so I know that sine is going to be positive, cosine is going to be negative, and tangent is going to be negative. And so I'm going to go ahead and write that out at the very beginning so that it doesn't catch me later. Okay, now if we look up the formulas for sine of 1/2 theta, and we're in degrees here, but either way you look at it, you're going to get the same values. So if, sine of 1/2 theta, if you look back up at the top of your notes, this is going to be a positive square root of 1/2 times the quantity of 1 minus cosine x. Now, cosine x, or in this case cosine theta, is already given to me. And keep in mind that theta here is in quadrant 4, so cosine of theta is positive. This is not so much things that you have to keep in mind as you're solving through these problems, but I don't want anyone at the end to think that they're supposed to put in a negative or a positive. Always on these half angle property problems, you figure out where your theta or your x is, what quadrant it's in. That tells you whether your answer for a sine of 1/2 theta should be positive or negative. Okay? All right, so let's finish out solving this one. So then I would have the square root of 1/2. And what is 1 minus 15/17? If you think of this 1 as a 17 over 17ths, and I do the subtraction, I get 2/17. And on many problems, this works out quite nicely, where you get some cancellation, and my answer is square root of 1, which is 1 over square root of 17. Okay, and that is your answer. All right, this is totally fine for an answer. If you want to simplify it, you could. At this point, though, we're not worrying about simplifying radicals in the denominator. Okay, so now let's find cosine of 1/2 theta. We already know our answer is going to be negative, so I'm going to go put that in. I found it right up there. And very similar formula, except it's 1/2 1 plus 15/17. Okay, so don't forget the negative. Square root 1/2. Okay, so this would be like 17/17 plus 15/17. So that is going to give us 32/17. And it doesn't cancel out all the way, but this does end up being a 16. And square root of 1 times 16, or square root of 16, is 4. And square root of 17 is my denominator. You could simplify, but you just don't have to. And again, notice that sine and cosine have the same denominators. All right, that's going to make it very convenient when we're figuring out tangent of 1/2 theta. Because what you could do is go back up to the top of the paper, take tangent of 1/2 x, and figure out which formula you want to use. Or you could do things the efficient way and divide sine of 1/2 theta by cosine of 1/2 theta, or 1 over radical 17 divided by -4 over radical 17, which we've seen many times. This is just going to give us -1/4. And notice that it matches up with what we said at the beginning, that tangent of 1/2 theta would be negative, and it is. And that's how all these problems work. Now, if by chance what they gave you was sine theta, you would have to draw a triangle to figure out what cosine theta would be. On most of these, you'll find that you're given what you need, and you don't even have to draw the triangle. Okay, now let's talk about proofs. Everybody's favorite. Okay, so again, when you're doing these proofs, you are trying to decide which side to start with. Always easier to start with the more complicated side, or I don't want to say always. The key is on some of these just figuring out which one is truly the more complicated side. On this problem, it's pretty obvious. And what we need to do here is we need to add these two things. And we've got some formulas we can use. And be easy on yourself. Okay, let me go back to the front. I have 3 different formulas for tangent. Okay, one of them has a very simple denominator. Let's choose that one. So tangent of 1/2 x would be 1 minus cosine x over sine x. So let's replace that. 1 minus cosine x over sine x. Okay, plus. Now this thing is also probably going to be a fraction, and what would be nice is if I could figure out one that also had a denominator of sine x. And just real quick as a side note, some of you might be thinking of using like tangent as sine over cosine, and that would work, but then I would still have to use some other formula for sine of 1/2 x and cosine of 1/2 x. Here, I get something I'm extremely familiar with. I don't even have to deal with the half angle or double angle or anything anymore. Okay, so back to cotangent of 1/2 x. Cotangent of 1/2 x is just the reciprocal of tangent of 1/2 x. So if I want my cotangent to have a denominator of sine, then what I'm really looking for is where is tangent of 1/2 have a numerator of sine. Okay, so let me write this out here to the side. Okay, from here to here, this tells me, and this is helping me on my proof, this tells me that cotangent of 1/2 x is equal to 1 plus cosine x over sine x. Okay, so this is, I'm getting it from here and here. Okay, I reciprocated them. All right, so let's use that in our proof. And this is definitely a step that is okay to write. This is not a giant leap. This is just basic plugging things in for the identities. Now look how nice this is. I have the same denominator. I love that. And the fact that cosecant is in what I'm trying to prove is nice that I have a sign in the denominator. Okay, so let's write all this out. 1 minus cosine x plus 1 plus cosine x. Look at this. The cosines cancel. And I have 1 plus 1, which is 2. And we've seen this before. 2 over sine x is 2 cosecant x. And obviously you could show more steps here. I wouldn't want you to show many less steps than this. But this is a way you could use a proof, and I really didn't use a whole lot of new material. I just had some new properties that I used. Okay, let's look at this next problem. This next problem is a little bit weird. As you notice, there's a lot going on. Okay, so let's start by writing the side that we start with. Hopefully obvious here is we start with the left-hand side. Okay, so what I want to do, hopefully you're thinking this, is I want to multiply by the conjugate of the denominator over itself. So I'm going to rewrite my problem and do that. I just realized I need to erase up here because I wrote plus instead of minus. Okay, so now I want to multiply by the conjugate of the denominator. That would be cosine 1/2 x minus sine x, which ends up being the same thing as the numerator. And it may be annoying to write all this out, but it's not difficult to write all of this out. Okay, so when I multiply through, I have cosine 1/2 times cosine 1/2. That's cosine squared 1/2, or cosine of 1/2 x squared. Okay, outside would be minus sine 1/2 x cosine 1/2 x. Inside would be minus sine 1/2 x cosine of 1/2 x. And then last would be plus sine squared 1/2 x. Now you already may see what could be happening, but let's go ahead and multiply through the denominator as well. It's almost the exact same thing, except you have this minus sine 1/2 cosine 1/2, and then you have a plus sine 1/2 cosine 1/2. And then you have minus sine squared 1/2 x. Okay, and notice that I haven't plugged in any of the formulas for cosine of 1/2 or sine of 1/2. That's because those things are square roots, and that would make this even more complicated. Let's go ahead and do the algebra steps and simplify and cancel and everything that I can. Okay, obviously in the denominator, we knew that would happen. Okay, look what's happening in the numerator. Now what I'm going to do is I'm going to take this slow and I'm going to write down two terms that I think should go right next to each other. Sine squared 1/2 x plus cosine squared 1/2 x. And then these two terms in the middle actually combine to be minus 2 sine 1/2 x cosine 1/2 x. And I'm just going to rewrite the denominator. And we're going to see if any of these things simplify using either maybe double angle, maybe half angle, or maybe other things that we've seen. Okay, I'm writing pretty big here, so I'm going to scroll this up so that I can have some more space. Whoops. Okay, so look at this right here. Sine squared 1/2 plus cosine squared 1/2. That's the Pythagorean identity. That's 1. Okay. Now look at what's written next. This looks like 2 sine A cosine A. That's the double angle formula for sine. So this is sine of, it would be 2a. A in this case is 1/2 x. Okay, so let me repeat this. 2 sine cosine is sine of 2, whatever your argument is. And in this case, our argument is 1/2 x. So notice what happens here. 2 times 1/2 cancels, and you're left with just 1 minus sine x. Okay, now let's look at the denominator. This is another double angle formula, cosine squared minus sine squared, except, and this is for cosine of 2a, but here in the a or the x is actually 1/2 x. Okay, so just to clean this up, I'm going to rewrite what we have. 1 minus sine x over cosine x, and that this is what we were trying to prove, we would be done and happy and everything would be right. Okay, but it's not quite what they have here. Notice that what they have here is another denominator that's strange. And since we can't work from both sides and meet in the middle, I need to get from what I have here to having 1 plus cosine in the denominator. So what I'm going to do, and this is the weirdest part of this problem, is I'm going to multiply it by 1 plus sine x over 1 plus sine x. We don't normally do this to get a strange denominator, but you can. Okay, so in the numerator, I have 1 plus sine x minus sine x minus sine squared x. And in the denominator, I'm not quite going to, I'm not going to multiply that through. I'm hoping that that cosine x will cancel, actually. Okay, so look what happens. 1 minus sine squared. What is 1 minus sine squared? It's cosine squared. So now I have cosine squared x all over cosine x parentheses 1 plus sine x. Okay, so now one of these cosines cancels with that cosine, and I have exactly what I was trying to prove. This is a strange problem. In fact, on your assignment, you're going to have this exact problem to work through again, just to get more practice at it. Okay, let's look at the, was that the last problem? Oh, it was. Okay, bring your questions to class.